Okay. Firstly, I'd like to thank Tritium for inviting me to present today. I'm Steve Geary, Managing Director of One Sightsolutions. For those of you that don't know One Sightsolutions was formed in 2008. We're a UK-based company based in Hampshire, some 40 miles west of London. We have 36 staff within the company, and we have a wide range of skill sets ranging from controls, IT infrastructure, electrical and mechanical expertise, software development, and IoT specialists. So what I'd like to run through today is what the One Sightsolutions do, firstly. And then I'm going to cover a demo of what we're using within our in our office environment. We've actually utilized a tool, that a visualization package, if you're not familiar with it, called Reflow, that I'll run through Reflow. And then I'll show you how we're monitoring within the environment, space, occupancy, temperature, air quality, EV, and electrical monitoring. Okay, so I'd say that there's 4 core areas to our business. The first one being distribution. And I'd say we've probably got the widest range of N4 ported products all under one roof. So we have Tritium products. So everyone, I'm sure, is familiar with the Jace and the Edge 10 controllers. We have the ISMA Controli Mac 36 controller as well, along with their associated I/O and terminal units. We have Distech controls. So we have the EC Boss controller, again, along with their terminal units and controllers. We're a distributor of Phoenix Contacts range of controllers, which includes the ILC 2050 controller, which has Niagara embedded on board. And then finally, we're just about to launch, when Niagara 4.13 is released, the new VIA Hub. The VIA Hub is actually slightly different to the other controllers, because this will be the first product that's been released with containerized Niagara on board. So Niagara will sit as a Docker container on board that controller. That will be the first subscription as a service model that will also incorporate LoRaWAN on board and 4 and 5G capability. So something very unique to the market space. So we believe that we have a very wide range of products for our customers. We have unrivaled customer services and after-sales support. We have a vast industry experience and product selection for different alternatives to try and meet our clients' needs. We have industrial leading technical support team, and we feel that we have virtually every single solution to meet our clients' requirements. So the next part is training. Mike's already mentioned about the TCP training, and we are proud that we've been awarded 3-time winner of Contribution to Training Award at the Building Controls Industry Associations, or BCIA, for the delivery of the training that we've put out into the marketplace. When the pandemic first hit, we were the first company to fully deliver the TCP training course remotely, and we still continue to deliver that today, typically every 3 or 4 weeks to full classes. But we've also started offering bespoke one-day courses that cover things such as security masterclasses, and we've also introduced now an advanced Niagara 4 IoT course. And this is looking at data structuring, a deeper dive into tagging and hierarchies, templating for mass deployments, and working with modern IoT protocols such as MQTT and APIs, and then gaining the insights into JSON data sets. If you're not aware, we've also developed a OneSight TV channel. Now, this is a free channel that's available to everybody on YouTube, and we currently have over 7,500 subscribers, and we've generated approximately 100 videos on there. And I actually looked at the numbers today, and we're rapidly approaching 1 million views. So this is really worth checking out if you're not familiar with it. So area 3 of the business is around projects. Now, we need to be very careful as a business delivering projects and being a distributor that we don't compete with the customers, the systems integrators that we're selling products to. And we always make sure that we don't. So we work in the area acting as an MSI, or a master systems integrator. And for those of you who aren't familiar with this, this is where we work directly for the main contractor and act as a safety net for them to ensure that their building is smart enabled and delivered to the specification within their projects. In many cases, we also advise and assist with defining the scope before the trades are awarded contracts. Again, we're fortunate to have been awarded from the BCIA again the Smart Buildings Project of the Year award for a project that we delivered at 80 Charlotte Street in London. And this is the new headquarters for one of the major consultants, Arabs. And what we did within this project is we oversaw the smart enablement of the BMS, the lighting, the lifts, the security, access control, energy, people counting. We installed a LoRaWAN wireless network system and in-ocean systems as well. And then all of this data was pushed via within the UDMI format over MQTT to Arab's custom cloud. What we've also done, though, is we've now developed a sleek modern web interface called Smart Building Connect. And this will assist an MSI with tasks such as asset management, QR code creation, live network monitoring for commissioning statuses, and validation of MQTT payloads. And this is something that we will be offering out to our partners to help them deliver MSI projects. In addition to this, it's often the case that when we deliver these smart enabled buildings, on day one, the customer or FM providers do not have a platform that they want to send the data into. And as I'm sure you're all aware, that MQTT is fire and forget. That historical data from day one is lost. So we've developed a data warehouse that will store all those validated payloads and make all that historical data available that can then be replayed via a well-documented API. And again, this is available to the marketplace. And the final area that I'd like to cover is development. So as you can see, we have a whole host of different types of drivers that we've developed. Now, I'm not going to go into too much detail on these because I'm going to cover most of these as we go through the demonstration. But what I'd like to point out is that the development is often driven from hurdles that we've seen within projects, and we've developed them to deliver and complete those projects and then made those drivers available to the market space, which you can procure these drivers over Tritium's Niagara Marketplace that will enable you to help get your projects over the line as well. So before I jump into the demo, I'd like to give you a high-level overview of Reflow. So for those of you that don't know, Reflow is a graphical overlay for Niagara that is installed as a jar file. And personally, we like to use it as a business because it really helps us speed up our engineering time when we're delivering our projects. It's also got responsive views built in. So when we're resizing the data from dashboards, we're able to view this on mobile and tablet views without any additional engineering. It also has a floor plan creation tool in there, which is a really nice way of us visualizing that I'll show you in a moment of how we can add additional layers to look at areas within our space and be able to visualize that. With good naming structures, creating well-defined folder structuring and tagging, it makes it super quick to create equips or devices en masse. And an equip is essentially a group of Niagara points that we used to seeing within our Niagara stations. One of the things we have noticed is that it can be quite restrictive in how we can actually create our dashboards, but we see that also as a positive because then we can have multiple engineers working on the same projects, creating multiple pages and it looking uniformed when we go to deliver that. So we actually feel that that is a benefit. So one final page before I go into my demo is just to give you an insight that from an engineering perspective, once this has been installed onto your station, I can see here that I've got my Niagara station and then I can view my reflow points. These are actually can be viewed without Workbench. So provided you've got your web browser and internet connectivity, you're able to engineer your system live over the internet without Workbench. So on to the demo. So this is a demo of our Hart House office, and this is the landing page for our office, and it's laid out with a number of card stroke widgets in how we've set this up. So if I start from the top left, we've got the instant power for our building, and then coming across, we've now got a total energy consumption history, which is just 15-minute histories that are coming in for me to be able to view. We collect data then from our EV chargers, so we can see exactly how many chargers we've got free. And this data is being pulled into Niagara via MQTT. Underneath, we've got the building occupancy. And this building occupancy data is coming from we've got a people counting sensor system within each of our 3 floors within the building. And this data is sent to us over an API, again, straight into Niagara. We have 2 people counting sensors, one at the front door and one at the rear. However, we are using these sensors and pulling the data in via MQTT. Now, the reason why we're doing this and not using the other system is that MQTT is event driven. And this is a really useful tool for us to get live data to for an accurate level of how many people are in the building. So in the event that actually we have an emergency and we need to leave the building, we can go onto our mobiles. We can actually see whether there's anyone left inside the building from that dashboard. We've got a number of desks within the building that are assigned as hot desks. And again, we can see exactly how many of those are being occupied. And that data is being pulled through from our API. Straight out of the box as well within Reflow, there's the ability that we can go and subscribe to APIs to pull weather information that can be displayed that give us live weather data as well as forecasted information. We've installed a LoRaWAN network as well within our office, and this is how we are able to monitor what our meeting rooms are free via occupancy sensors from our meeting rooms. And then we have a widget here that I can click into to go to our alarm console, which again is straight out of the box within Reflow. But I'll talk about a little bit more about that later. So if I come through to my page, what I want to talk through here is about the navigation of the software and how this is laid out. So starting at the top here, you can see that I've got a home, I've got spaces and floors, equipment, histories, alarms, schedules, and then I've got drop down for some other demo systems within our demo. I've also got some cards laid out, one for each of the floors. So for the basement, the ground, and the first floor that I can navigate to. And then underneath, we've broken it down into some of the equipments that we've got, but we'll touch on those equipments later. So if I now want to go down into the basement, I'll click on my basement card and I'll pull up our floor plan for the basement. Now, these floor plans have all been created within the software. And as I mentioned earlier, we've overlaid data. So we have some air quality information coming in here where we have data coming from the LoRaWAN network, where we've got some air quality sensors that are measuring CO2 and VOCs within the meeting rooms. If I go into my temperature, I've now got a temperature overlay. And again, from those same sensors, we're now pulling in the statuses. And we have the capability where we can render particular areas within our environment and set red, amber, green statuses dependent on what the actual temperatures or air quality is like. Now I'm going to drill down into occupancy. And with our people counting system, this will actually measure when people are sat at desks. And as you can see here, the red areas are where people are occupying spaces, and the green areas are where desks are available. It is worth pointing out, although we have got a people counting system in place within here, prior to having that system installed, we did use LoRaWAN sensors that were installed underneath the desks, and they were very effective. They picked up, they detected motion and also heat as well. Moving across to the top here where I've got some room control, if I click into the room control here, we've actually got some room control for some of our meeting rooms. So if I click into my basement meeting room, we've actually created a short video just to run through some of the functionality within this meeting room. So if I start that video off, so we've got a camera installed there so we can actually see what's going on for the purpose of this demonstration. It's worth pointing out that the projector we've actually written an API driver so we can take the data straight out from the projector and into the API. I'm now going to turn the projector off. So we'll click on that and we'll see the screen go out. We then go to the mood lighting and we'll switch the mood lights off. And they've now gone out. We've got control where we can put the main lights on. We're taking data as well from the AC units via an API. And we can control the set points. Coming down into meeting room bookings, we've developed a driver for Microsoft Office 365, and we're pulling that information into Niagara. And then we've just got a tabular form of some of the energy metering. What I wanted to show you as well is some of the responsive panes as well. So by just going through the web browser to more tools and into the developer tools, we can now resize our page to simulate an iPhone. So I've got an iPhone here now and just showing you how it resizes automatically without any engineering. And we'll change that now and put that into a a view where we'll see an iPad, and again, it will resize. And then back to the screen. Okay, so ultimately, typically how we are laying our spaces out is with equipment or devices as we typically know them within Niagara. So we've got ours laid out here where we have Airthings air quality sensors, and we take the data from these air quality sensors. These will talk, these will communicate via a hub. Their hub will then talk to Airthings cloud, and then we pull the data from our OSS Easy API straight back into Niagara. We've got some air quality sensors from LSIS that are LoRaWAN sensors. We typically take the data from a chirp stack server and then pull that information over via MQTT. However, there are devices and gateways in the market that you can communicate with and pull that data straight out as BACnet IP as well, which makes it pretty simple to integrate that data in. We have a fair amount of metering within such a small office space. We've got probably over 30 meters within our office. So we're measuring all of the different circuits that we've got. And we are pulling that data in via a couple of sources, one via SNMP and one via Modbus RTU. We've also collecting the data in from our HVAC devices, which is a Mitsubishi system. How we've pulled this data in is we've taken an Intersys gateway where we'll talk directly to the units and then present that data as BACnet IP that we can feed in. And if I now maybe click into one of our equips, you can then see all the facets that are associated with that particular equipment. And then you've got the capability where you can then change maybe your set points from here or change the status or control direct from one of these equips. So moving on, I'm coming through now into histories. And as you can see, we've got a large number of histories. So Reflow will automatically pull the histories out of your Niagara station for them to be viewed. And I've got some landing cards of some of the particular histories that are important to us within the building. So if I maybe click on whole building energy to start with, and what I've pulled through here is the last 7 days worth of data for our office environment. Now, what I'd like to do is I'd like to overlay our occupancy data that we're also recording and see how that sits alongside it. So I'll click on it, add in occupancy. Now I can select my building total occupancy and I can add that. And as you can now see, the correlation between our occupancy, which is in green, and our energy consumption is very, very close and has an impact. However, I can see that there's an anomaly here at 12 o'clock on the 29th. So what I'm going to do is, as I know that I mentioned we had a large amount of metering, we have EV chargers. And I've added the EV charger meter to this. And you can see that actually over the weekend, somebody's been charging their vehicle. So it's worth pointing out that we have a courtyard behind our offices that has lots of residential dwellings, that we've actually allowed the residents to use our charging devices out of hours. So this is a really neat way for us to track exactly what energy consumption is, pulling that back, and then we put it into a third-party system that we can then produce the bills to provide to them on a monthly basis. So moving along one more, I mentioned that there was an alarm console within the software. So this alarm console gives us the capabilities to just give us a very high level overview of where the alarms are. And then if I want to then drill down to those alarms, I'll come into my medium alarms, and I now get a better insight of those alarms drilled down. Again, I have the capabilities here where I can then come through, I can export my alarms out, I can acknowledge them, I can put hyperlinks to them, add notes. And again, I can drill down and see a further summary where I can still go through and acknowledge those alarms and just look at them in finer detail. Skipping through one more, we're coming to schedule. So there's a typical schedule viewer that we can have within here. We've got some set up for our HVAC within our environment, where we have them set to come on at 7:30 Monday to Friday, go off at 6 o'clock. And equally, we can drag and drop these just to change if we need. We can create special events. And again, it's just pretty straightforward, clean scheduling that you'd be used to seeing anyway. So I've mentioned a lot through the presentation around APIs and our OSS Easy API driver. But what I wanted to demonstrate here is it's not just taking that data to use it to integrate with different building systems. There are literally thousands of APIs available in the marketplace that you could be bringing and pulling into your Niagara platform to visualize and engage with your staff or visitors. So I've just got a couple of examples that I'd like to run through with you. So I've got one here for the London Underground. So what we've got here is we have a live status for all of the different tube lines that we've got within Transport for London system. It's worth pointing out that in our old office environment, we used to have a Dali lighting system, and that Dali lighting system, we could make the lights create any color. So actually we had some logic set up for demonstration purposes in our demo room, that if there was a problem on, say, the central line, we could get the lights to flash for 10 seconds red, just so you'd indicate that there was an issue with that particular line. Another one I'm going to show you now is train times. So we've just got some of the local train stations to us where we can pull through. And if I go into London Waterloo, we've got the departure time set up here where we can get live statuses of those departure times and display that within Niagara. Again, the purpose of this is just trying to demonstrate that there are lots of examples of how you might want to utilize that. So, you know, again, we've had customers wanting to look at parking spaces local to them. It might be the status of what the road network's like in your local areas. But that information can be fed in and displayed and used as green screens for your customers, all from one single driver. One of the other drivers I wanted to show you as well is that we've created an OSS Teams tool. So this is a tool that will enable you to get notifications come up on your phone or tablet. And again, I've got a little demo here. And that calls through, and then it comes through to your alarm. So again, it's the kind of things that we're used to seeing with apps like WhatsApp, but this is just a neat way of somebody being able to get an alarm sent to their phone without having to log in and view that. Okay, I want to give you a bit of a use case that came up over recent weeks, and this is around EV charging. So these are the chargers that we've got externally to our office, and I've recently taken delivery of an electric car. The car had a specification that it should be able to accept 11 kilowatts, and on the first day of bringing it to work to charge it, I sat down on the app with my technical director, who had his car plugged in on the charger next door. And he was showing me on his app that he was pulling 11 kilowatts. However, from my car, I was only managing to pull 7 kilowatts. So we thought, what must the problem be? So first we changed the leads and thought maybe I've got a problem with my lead. Tom used my cable, I used his. And actually I'm still only pulling 7 kilowatts, Tom's pulling 11. So we then changed chargers, and actually the problem was still there. Fortunately, because of the charging system that we've put in place, we were able to export the data and view this as MQTT. And what we can see here is EVSE1 is Tom's car and EVSE2 is my car. And I can see that my car was pulling 7.4 kilowatts. Tom's is pulling 11.7 kilowatts. And when we read down at the data, Tom's we have a 3-phase supply. Tom's has got 16 amps being delivered on each of the phases L1, L2, L3. Mine only has 15.5 on L1, 15.5 on L3, and I'm pulling no current at all on L2. So my car actually had a fault with it the day it came out of the factory. Now, I could have taken delivery of this car and I could have not noticed, thought 7 kilowatts was acceptable. I would be charging at a third of the speed that I should have been charging at. But more importantly, because I would have been lost straight down the neutral, I would have been paying a third more in my energy consumption every time I charged it. I took this data and this MQTT feed to the garage where I purchased it, and they thought I was quite strange. But actually, they then put it on the diagnostics machine and confirmed that there was a fault with my car, and it then sent some new parts out to rectify it. So it's just a really good use case of showing how we've used that information and how we can embed that information into Niagara. So one of the other things that I wanted to run through is we do lots of metering projects for our systems integrators who are delivering EMS projects. And one of the things that we notice, certainly in specifications where there might be hundreds or even thousands of submeters being installed within a building, is it can be quite cumbersome to try and pull that information into Niagara, or you might have to develop some quite complex logic So what we've developed is an OSS easy history export that enables you in a matter of minutes to be able to create a single CSV file in a multi-column format and then have the ability to export that data securely over FTP or SFTP at a given frequency that you want that data to go out. And we found this a really successful route that in the platform that we use, iBuilding Energy, when we're associating our names, we're actually just taking this history name to the history name that we'll call in the data import. So it makes it super easy for us to engineer and deploy those systems. What I wanted to do then is just show you finally just a couple of screenshots about how we then take that data and how we can represent that information in fiscal terms. So I've taken the same information that we looked at in Reflow from a history point of view, but I've actually assigned our occupational hours of our working hours for the environment we're in. So the green area here is our working areas, and the orange is out of hours usage. And what we can see here is that 42% of our energy consumption is being consumed when no one's in the building. Now, when we looked at this and investigated, we actually recognized that this is a really good profile because we have servers that are running 24/7 on site, and these servers are typically using about 1.5 kilowatts of consumption constantly. So we can see that we haven't got much load outside of that. And then externally, we've then also got this charging that we are now monitoring and recording that we can then do the recharging onto the residents. And then one final screen is looking at that. We've put our cost contract for our environment in here so we can now view this in fiscal terms. And I can see exactly what the cost is from the base load of, so for this week, it's £97 for out of hours usage, as opposed to £140 for the week. And then I've got all that data I can export out. So hopefully that's given you some insights about what we do, and I appreciate this is just a bit of a snapshot about what we do here at One Sightsolutions and how we use Niagara. But if you've got any questions, then feel free to let us know now, or feel free to reach out to us after, where we'd love to help. Thank you.
All right, thanks, Steve. And as Steve already mentioned, if you have any questions, feel free. We already answered some of them during the presentations, and as said, we're going to publish them all on our website after this webinar.
Shall we go through the outstanding questions now if we have time? So,
yep, we have some time left, so feel free.
Okay, so just going to work down the list. It's Tom here, Technical Director at One Sightsolutions. Hello, everyone. We'll try and get through as many questions as we can. So I'm gonna go for Greg Arden. You've mentioned that you have structured the data via UDMI. How are you implementing this? So in the smart enablement projects that we've delivered with Niagara 4, Tridium released a tool called the JSON Toolkit a number of years ago, and that allows flexible handling and construction of JSON payloads based on any point or any data within the station. So you essentially use it with queries, BQL queries within the station, and you can take Niagara point data from any device, any driver, any protocol, and structure it however you like. Once you've got your JSON payload out the other side, you can then submit that via MQTT API or any other mechanism. Hope that answers that for you. Let's go for Andre. Can the system get the energy consumption from an energy provider, or does it have to be entered manually? So Niagara can retrieve energy data from anywhere that has a protocol API or option that will allow you to do so programmatically, whether it's direct from meters, whether it's from suppliers or aggregators. You can get that information and store it and handle it. Equally, you could also provide fields or data entry options for doing it manually.
I would say probably just to add to that as well, certainly within the UK market space, you can request to have what's called a cat box fitted to your fiscal meter, which is a customer access terminal, and that will give you the ability to get kilowatt hours and kilowatts as well, and then you can then feed those direct into a logging device that you can then record your own information and then put that in from a standard protocol.
Excellent. Got an interesting one from anonymous attendee. LoRaWAN driver available in the marketplace. So the way we've done our LoRaWAN integration that Steve brushed over there, depending on how you've deployed LoRaWAN, whether you're doing it on a large scale with a LoRaWAN server such as ChirpStack or via a gateway from the likes of MileSite and leveraging their BATnet server or an API, Niagara's already got a number of options that will allow you to interface. So typically those options would be MQTT or a REST API, or alternatively you might use BATnet to do it with it if you have a compatible gateway.
I'm going to say it is worth pointing out as well, we have developed a ChirpStack driver should you want to take data out as I'm from ChirpStack as well.
Fantastic. Wesley Sapte, hi Steve, have you connected any Sigfox sensors to your system? So I'll answer this one. So Sigfox, been aware of it for a while as a long-range low-power wireless solution. However, over in the UK especially, I can't really speak for the US market, it hasn't really gained much traction compared to the likes of LoRaWAN. So I on one site, no we haven't. Not sure if the Tritium guys are aware of any Sigfox integrations.
Not at this point, no, but we can investigate.
Yeah, maybe we'll make a note of that one, and I'm sure the Tritium guys can reach out and get back to you. Matthew Russell, I really like both the public transport and the detailed EV charging data, both great ideas. So they're fantastic examples of MQTT and API integration. Gary Bark, quick answer here. So we're using CTEC EV chargers, ChargeStorm connected twos. Is it possible to integrate any proprietary communications devices? That's a good question, and pleased to say the answer is yes, because Niagara or the Niagara community is an encouraged extensible development environment. So you are encouraged to develop on the framework and solve challenges that aren't already solved with off-the-shelf drivers and products. So short answer is yes.
And I would also say that if ever we're asked from a customer about can we integrate with this, I would just go straight onto the internet, type in Niagara third-party drivers. You will go onto Tritium's website and you will get a complete list of all the drivers and who the developers are of what those drivers are. And 9 times out of 10, there's something there.
Okay. Greg Arden again with regards to JSON and MQTT. Just a quick answer. Yes, you would be structuring the devices or UDMI assets typically in a folder structure within your station where you produce the payload. It is quite heavy to do it that way. And I did actually just remember that Tritium have released the Google GCP connector, I believe it is, or Google Gateway connector, which actually does handle some of the UDMI payload creation itself. So that's definitely worth looking into. Faisal Ahmed, in our upcoming project, we intend to incorporate video surveillance on Niagara. Please recommend it to me. Video surveillance is an interesting one because typically the video surveillance industry doesn't conform to too many standards or every manufacturer's going it alone. There are some attempts such as ONVIF. In our demonstration there, our video integration was done via a Reflow module. Or a Reflow widget that allows you to effectively just embed web pages. So we have essentially got a motion JPEG video feed embedded on that Reflow web page. Tritium do have drivers for, I believe it's Milestone or MileSite video, as well as Axis video cameras. John Beadle, or is that one just gone? Oh, someone stole it. Okay. Andre again, connected to a JS8000 via MQTT and LoRa Hub means having an MQTT broker. If you're going to use MQTT, yes, you need an MQTT broker, absolutely. However, you don't have to use MQTT to integrate with LoRaWAN. Depending on the mechanism you've chosen to deploy, it can be done via an API, or as I mentioned, some gateways also now include a BACnet server as well, so you can map your LoRa points to BACnet objects and bring them in with a standard BACnet driver.
Tom, do you just want to touch on where you might want to use, when you might want to use BACnet and when you might want to use a full chirp stack deployment as well?
Yeah, so if we're talking about LoRaWAN, traditionally it's been designed to be a highly scalable solution. LoRaWAN's unique in the sense that there is no direct pairing relationship between any particular sensor and any particular gateway or hub, as we may be used to with pre-existing wireless technologies. Instead, the relationship is between a sensor and a LoRaWAN server. What this means in the bigger picture is if you've got a large estate, numerous sites, etc., you can centrally locate on your network a LoRaWAN server. A popular open source one's called ChirpStack. And you could plug as many gateways into your network and feed them back into that LoRaWAN server as you wish, which will provide you huge radio coverage, and you could literally put a sensor in your pocket and walk across any of your sites, fly halfway across the world, get back within range of one of your gateways, which feeds back to your LoRaWAN server, and it will just work. So if you've got a particularly large estate or distributed environment and you want to deploy a single unified wireless sensing infrastructure, you should deploy LoRaWAN like that, with a dedicated LoRaWAN server like ChirpStack, MQTT broker, and distribute your gateways. However, for the smaller deployment where you just want a quick and easy wireless solution that outperforms anything else on the market, you might choose a gateway that embeds a LoRaWAN server and provides you a model of convenience, such as a BACnet server on board, which means you could register your sensors directly to the onboard LoRaWAN server on your singular gateway, and then do a BACnet object mapping for some temperature humidity sensors, for example, and then pull them straight out via BACnet. So it's really about the size of your deployment where you make that decision. Matthew Russell, which sensors were you using for your under-desk occupancy, please? Just like PIRs, where the occupants are often static enough that the PIR doesn't see them. So when we were doing this with under-desk sensors, there's some LoRaWAN offerings, several different manufacturers. I won't name specifics, however, really accurate and good ones don't just use motion or PIR. They will typically incorporate an infrared temperature sensor as well, and they will detect body heat. So not only motion under the desk, but they'll detect body heat through someone sat in front of it as well, and they'll run an internal piece of logic with sort of like a timeout or a fail-safe. So if you've just stepped away from your desk, it won't immediately mark the sensor as unoccupied. It'll go into sort of a pending state for 10 minutes or whatever before it clears the desk. So I'll say research on the LoRaWAN element. Can't remember the exact model. I think it's Elsys, but MileSite do some, NetVox do some, and there's some specialist brands that only do under-desk sensors as well on LoRaWAN. The system you saw in the demonstration live, however, was a grid of ceiling-mounted sensors designed to identify any person within the space, and that allows you essentially to draw a box around any object on the floor plan and say, I want you to let me know if someone is there. Hopefully that answers that somewhat. How many more we got? Might be one for you, Steve. We've got Andrew Stokes. Any examples of customer benefits save and realize showing a return on investment using Niagara?
Yeah, well, I would say that we are using it, you know, as I've mentioned a lot, we're using it in lots and lots of cases, certainly for energy management systems where we use Niagara to collect the data from all of the different metering and pull that data through. Ultimately, the savings are huge. If I look at just in our small office environment, on us being able to control and understand exactly what our usage is out of office hours and ensure that when we're locking that door at night, we know that we're not leaving anything on that shouldn't be on. It's exactly that, you know, a really good example. We've got a One Systems integrator that is collecting 300 stores back onto a Niagara server, and they are basically doing that across 300 sites where they know exactly what the consumption is. And rather than waiting for the bill to come in at the end of the month and realize actually that an occurrence has happened, they can know instantly. They can know from an alarm that can be set up and configured, or they'll know that when they come in the next day. I think that's probably a good scenario around it.
I think I'm just going to jump in there with another very real use case that's sort of become more popular after COVID-19 and the pandemic, and that's understanding space utilization, understanding how your space that you're paying for is utilized. And the analogy I like to use is a 10-story building with 100 desks per floor, and your employees come in, and by putting desk occupancy or people counting solutions in, or traffic flow management solutions, you can quickly identify if you're only using, say, 20-30% of your desk capacity across all of your 10 floors. So a sensible decision might be, okay, I'm going to only occupy the first 3 floors to 100%. And thus you can make energy savings, cleaning bill savings, on all of those other floors. You don't have to run your plant on those floors. You don't have to light the floors, etc. Simple stuff such as emptying bins and stocking vending machines, for example, refilling coffee machines. If you know how space is utilized, you can make really intelligent decisions on what to do with it. May go as far as selling off or repurposing.
Yeah, I think in your example there as well, Tom, that we work with a university that's done exactly what Tom's described there. And what they found is that they are monitoring, say, lecture theatre spaces and that have capacity for 100 people, when a lecturer might be booking that space and only taking 10 people into that space when they should be using a different room. And they're constantly reinvesting in buildings and building it when they're not actually using their space to its full potential.
Okay, I think we've got one more question. Faisal Ahmed again. How does it support Distech's ECX light for DALI color shifting and integrates with Reflow or OneSight? So that functionality is provided by the Distech DALI controller or DALI interface. Once you've plugged it into Niagara and you're absorbing the Niagara data, which with the Distech ECX line is typically LAN or BACnet, you can do anything you want, because as far as Niagara is concerned, you're just reading and writing to points.
Thanks, Tom.
I think that's just about all of them.
Okay. So in this case, I think well, 10 minutes left, so we are quite good. Yeah, I'd like to thank you all, Steve and Tom, for joining, and all participants for joining as well. And yeah, I'm going to close this now. Thanks again for joining, and have a great day, and see you to in the next webinar in about 4 to 6 weeks from now. Thank you very much.
Thanks, Mike.
Bye.